which was these polyatomic ions to memorize. And we had discussed some stuff about these here the other day. One of them is that most of these that we are memorizing have a suffix of
ATE.
ATE. And what is it that all of them here have in common that have the ATE suffix? They contain oxygen, and they all have a charge that is negative. Okay, but their charges vary. And part of the reason why we memorize these is because these are the ones that are most commonly found out in nature. If we were to find nitrogen out in nature, it comes as nitrate. If we find sulfur out in nature, it comes as sulfates. And so these things were named long before we knew about how they were composed. But what you should know is that in addition to these, you do have the expectation of knowing those that end with a suffix of ITE. And the ones that end with the suffix of ITE, we can always compare those to the ones that end with the suffix of ATE. So for example, you were asked to memorize nitrate, but you should also know the formula for the nitrite ion. You were asked to memorize sulfate, but you should also know the formula for the sulfite ion. You were asked to memorize chlorate, but you should know the formula for the chlorite ion. And so we discussed this a week ago, but once again, how is it that the ITE suffix form varies from the ATE?
Just one less oxygen.
Okay, one less oxygen. Which one has one less? The ITE, exactly. And I don't remember if I gave this to you as a mnemonic, but one way to remember it is that the one with the ATE suffix, ate one more oxygen. So it's a way for you to learn that. The ATE, ate one more oxygen. So that means that if we went on to something like the phosphite ion, which is not listed on here, but this is the next question on your Socrative app, and you can discuss this with the neighbor. If we wanted to know the formula for the phosphite ion, what would that formula be? So take about 30 seconds here or so. 4, 3, 2, 1. And the correct choice there is a PO3 with a 3 negative charge. And that one comes from the fact that if you've memorized the phosphate ion as being PO4 with a 3 negative charge, the one with the ITE suffix has one less oxygen, so it's going to be PO3. The charge, however, will
Stay negative.
stay the same. Not only will it stay negative, but it will stay the same. So any questions on these? Okay, now, that means that if we went to something like carbonate, which has a formula of CO3 with a charge of 2 negative, and that's one of them that's on your sheet here, the carbonate ion. And you say, well, if we have the carbonate ion, that must mean the carbonate ion is, turns out there is no such thing as the carbonate ion. Just because we can write a name for it doesn't mean that it exists. There's some of them that do exist, some of them that don't exist. In the case of phosphorus, phosphate and phosphite both exist. In the case of carbonate, only the carbonate exists. There's no such thing as carbonate. Kind of interesting though, because some of you probably heard of carbonate before. Any of you heard of carbonate?
Yeah, Star Wars.
All right, and who was in?
Han Solo gets frozen in carbonate.
Right. And it also used to be one of the names of the original cloud storage solutions that was out there. Okay, but there is no such thing as carbonate. It's just probably a takeoff of this whole ate and ite suffix type thing. Likewise, you may have heard of Superman getting his power from kryptonite. From kryptonite. And there's a song by 3 Days Grace called Kryptonite. But there's no such thing. Is that and I think it's 3 Days Grace.
It's 3 Doors Down.
3 Doors Down. And I always get them mixed up.
Yeah.
So, all right. So with that in mind, Let's go on and write out some formulas. So we want to write out a formula for potassium nitrate. Again, if you don't have them memorized, have your sheet out. Potassium, you should know, based on its position in the periodic table. Potassium is going to be K with a charge of 1 plus. It's right here. Always has a 1 plus charge. Nitrate tells us that it has which element in it for sure? And nitrogen. What does the 8 tell us is also there?
Oxygen.
Oxygen. So that means it's a to memorize ion. Its formula is NO3 with a 1 negative charge. So just like before, we want to balance charges. The sum of the positives must equal the sum of the negatives. And in this case, do they or do they not? They're already equal. So we take one of each. The formula is KNO3. We go to the next one. Copper 1 carbonate. Copper 1 carbonate. We see the name copper 1. That tells us we're dealing with Cu that has a charge of 1 plus. Carbonate with the ATE suffix. That tells us this is a to memorize ion. Formula of the carbonate ion is CO3 with a charge of 2 negative. And again, that comes from your sheet right here, the carbonate ion. So now if we want to write the formula, we need to balance the charges. Which one do we need more of? Okay, and how many coppers do we need altogether? 2. So now the charges are balanced. We have 2 positives balancing the 2 negative charges. Formula becomes Cu2 CO3. Once again, the final formula is always written without indication of charge. We only show subscripts in the final formula. All right, we'll keep going if there's no questions. Okay, let's look at aluminum acetate. Aluminum acetate. For this one here, aluminum, we can determine its charge based on position in the periodic table. Aluminum will always have a charge of 3 plus. The AT suffix on acetate tells us this is a to memorize ion. So where do we have that? Not here. Right here. This is our acetate ion, C2H3O2, with a single negative charge. Now, of course, this one here, charges aren't balanced. So which one do we need more of? We need more of acetate. Good. So how many acetate ions do we need altogether?
3.
Okay. So now when we write the chemical formula, Al, what subscript comes after the aluminum? Nothing. And then what? Parentheses. Good. And then in parentheses, C2, H3O2. And then parentheses, 3. Now what these parentheses do is this. Now we've not used them before, but whenever we have more than one of a polyatomic ion, we place that polyatomic ion in parentheses, and then a subscript outside of those parentheses to indicate how many of that particular polyatomic ion we have in there. If you had a high school teacher that allowed you to put parentheses in there like this, that's wrong. These formulas are not written with parentheses unless there's more than one of a polyatomic ion. So if you include parentheses on here, I will mark it wrong on your exam. If you put it in master chemistry, it will not be accepted with parentheses around there. It'll only be here if there's more than one of that particular polyatomic ion. And we'll keep going if there's no questions. Next up, magnesium hydroxide. This one, by the way, goes by a common name of milk of magnesia. Milk of magnesia is found in things like antacids. So now if we want to write out a formula for this one, magnesium always has a charge of 2 plus. Hydroxide, OH negative. And this, by the way, is one of them. This is the only polyatomic ion that contains oxygen that doesn't end with an ATE suffix. Every other polyatomic ion that has oxygen in it ends with the suffix of ATE or ITE. So again, this is the only one here on the to memorize one that does not end with ATE as a polyatomic ion, but it still includes oxygen. So now, when we write this formula out, we need more of which one? Hydroxide. And altogether, we balance it with 2 hydroxide ions. So we have a single positive, we have 2 negatives here. If we write out the formula, it would be Mg. And then what?
Parentheses.
OH, 2, and what else do we need in here? Parentheses. That's right, whenever we have more than one of a polyatomic ion, we must include those parentheses. Because, of course, if we simply had written it as MgOH2, this tells us that there are how many hydrogens?
2.
And how many oxygens? 1. So this one here would not work as a possible formula, but is probably of all the polyatomic ions that we do, this is the most common mistake that people have. And that's because the hydroxide ion doesn't have any subscripts in it itself, I think, is probably why students do that. And the other one where students often make mistakes on it is when they use the cyanide ion, because the cyanide ion also has no subscripts in it by itself. So you do need to remember that when you have more than one of the cyanide ion, more than one of the hydroxide ion, you still need to include those in parentheses when you write those formulas out. Okay, let's try one more. Let's look at calcium chloride. Calcium chloride. Now notice this one here has a suffix of ITE. We didn't memorize those that ended with ITE. We did, however, memorize chlorate, which has a formula of ClO3 with a charge of 1 negative. That means that the chlorite ion has a formula of ClO2 with a charge of 1 negative. Remember, the charge doesn't change, only the subscript does. So now if we want to write the formula, we go to the periodic table. Calcium always has a charge of 2 positive, 2 plus. The chlorite, we just wrote its formula over here as ClO2 with a single negative charge. Which one do we need more of? Chlorite. How many more do we need? 1 more. So now that the formula is, the charges are balanced, the formula is Ca, and then what do we need next? Parentheses, then ClO2, parentheses, and then a 2 to indicate that we have 2 of the chlorite ions. Again, I just keep going if there's no questions. Go Go in the reverse direction. Let's say we have Na2CO3. Na2CO3. Actually, going the reverse direction is pretty easy because all we need to do here is to name the ions present. We do need to recognize the formulas of the ions. First one we should know right off the bat. This one here is sodium carbonate. And if you're not sure of the carbonate, come back here and you see that the carbonate has a formula of CO3 with a 2 negative charge. So this first one then is sodium carbonate. Let's do these. And by the way, I'll pass these two out here. Next two we're going to look at are FeSO4 and Fe2 SO4 in parentheses 3. And we want to arrive at names for these. And I'll pass these out so you can see that they are two different compounds. You can pass them to the back and then bring them forward on the other side. Now when you name these, we see the element Fe in there. And since iron is present, that's one of them here that has a variable charge. If it has a variable charge, what does that mean we need in its name?
Roman parentheses.
Roman numeral in parentheses. Good. So this is without the Roman numeral. We can simply say it's called iron sulfate. And this one here we can call it iron sulfate. We're saving space for the Roman numerals. Now to figure out what the Roman numerals are, we need to know what the charge is on the ions. So, what is the formula and charge of the sulfate ion? SO4 with the charge of 2 negative. Now, if we look at the formula, how many irons are we showing in the formula? Just one. So we're showing just one in there. What must the charge on this iron be in order to balance charges? 2 plus. Good. It's a 2 plus. Because a 2 plus cancels out with a 2 negative. So because this is a 2 plus charge here, that must mean that the Roman numeral is 2. We call it iron 2 sulfate. And in the next one, remember, sulfate will always have a charge of 2 negative. So its formula is SO4. SO4 with a 2 negative charge. But now, we look at the formula. How many sulfate ions do we have?
3.
There's 3 of them here. And each of those sulfates will have a charge of 2 negative. So with 3 of them here having a 2 negative charge, this formula shows how many irons. There's 2 of them there. What charge must each of these irons have in order to balance the 6 negative charges on the sulfates? 3 positive, right. So we're basically just working backwards here to figure out what those charges are. We have a 3 plus charge. That gives us a Roman numeral of 3 in the name, and we call it iron 3 sulfate. Now sometimes we have the positively charged ions. In fact, there's only one positively charged ion that we're responsible for in here, and that is the ammonium ion. And so if we were to use that one, let's say that we had a formula something like this. It is NH4 in parentheses 2S. We simply name the ions that are present. So the name of this first ion is the ammonium ion. This would be called ammonium sulfide. That's right, not sulfate. Because if it was sulfate, which other element must be in there?
Oxygen.
Oxygen. Or if it was sulfite, what other element must be in there? If it's ite, what other element must be in there?
Oxygen.
Oxygen. So either the ates or ites have oxygen in there. If it's just a single element in that portion of the name, we leave it as an IDE suffix. Yes, sir.
How do you determine which one goes in front? When you're naming it, like instead of ammonium sulfide, can't you say sulfur, like ammonium or something?
No, that's a good question. Here's how we do it. There's two ways to look at it. First of all, in ionic compounds, the positive ion always precedes the negative ion. Always. Okay? And it's also true when you write the formula. The positive always precedes the negative. So it's positive, negative.
Positive.
Always. In both the formula and in the name. Now we'll find out if you were to go on into organic chemistry, say a year from now, then organic chemists, when you get to more complex formulas, will actually trail the metal at the end. But that's because metals aren't very common in organic compounds. And so they attach them on at the end. But in the inorganic, which is what we're studying here, the convention is always positive, negative, and that usually means metal, non-metal. Just like we'd see them on the periodic table, metals here on the left, non-metals on the right. So just left, right, the way that we see them. Any other questions? Okay. Let's just do another one real quick here. Let's say that we have calcium cyanide. Based on its position in the periodic table, calcium will always have a charge of 2+. Cyanide now, even though it has the IDE suffix, is one of those to memorize one. Is one of those weird polyatomic ions. That's this one right here, Cn with a negative charge. So we have Cn with a negative charge. How many of these cyanide ions do we need?
2.
2. And so the formula would be parentheses Cn2. There we go. Ca, and then put the Cn in parentheses, and then the 2 outside. Any questions on these?